Welcome to Almost Here, Round the Corner Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
This is Richard Jacobs with the Future Tech Podcast. My guest today has been a tough guy to get, but well worth listening to. Gary Brotman, Director of Product Management and the Head of AI at Qualcomm.
Hi, thanks for having me on.
Very good. So tell me about your position as Director. What kind of AI projects is Qualcomm working on? I didn't know, I don't know if they talk about it very much, but what's Qualcomm doing in the AI world?
So Qualcomm, as you may know, has been a leader in on-device or a leader in mobile and edge-based compute. I mean, we've been powering smartphones with our Snapdragon mobile processors for the better part of the last decade, and we're really taking we have been over the past 3 years commercially, but really the past 10 years from a research standpoint, seeking out ways that we can improve and embrace machine learning, deep learning, just general AI algorithms on our processors across the board. Our focus is very much on device. We're not a cloud player like many of the leaders of industry and AI are really focused today. What we're doing is we're taking the heritage that we have in compute and mobile, and we're optimizing that to be able to execute AI algorithms and use cases on device without the need for a connection to the cloud. That's really our sweet spot.
Why this focus of on-device versus relying on the cloud? Are there trade-offs there?
Yeah, there's a few. If you look at the advances in on-device compute, it's not just about the improvement in performance. There's been a great deal of movement and improvement in energy consumption. And with that kind of combination, plus the readily available amount of data that's out there to be able to train AI algorithms, the timing over the past 2 to 3 years has actually been right for this transition from the cloud to the edge or to mobile devices. From a benefit standpoint, there are 3 key benefits that we look at. One is privacy. And even though consumers are much more accustomed to sharing personal data, I mean, social media gives folks an outlet to share thoughts and ideas and personal data, but even in those cases, not everybody shares everything. And when you get into specific AI-driven use cases where you're leveraging personal data like your voice or your face to do things like unlock a phone or to make a mobile payment, you want that processing to be done locally. You do not want to have to share the template of your face, which is really personal data, with a third party. If you can do that facial recognition on the device, you're really protecting the privacy of that data. And the secondary is performance. If you don't have to have a round trip to the cloud and you can do all that processing locally, the experience is virtually real time. That face unlock happens in a split second. Again, as a consumer, you really don't notice any of that latency. As consumers over time have become more accustomed to things being real time across the board. So privacy, performance, and then the third part is just general reliability. Because you have copious amounts of compute and the software algorithms that can run on a mobile device to deliver these user experiences, you really minimize the downside of potentially a connection breaking, or there be some sort of an unreliable connection that would force a user experience or device to become inactive or not be able to deliver on the consumer promise that it was intended to. You don't want to have to be dependent on a cloud connection to deliver a specific user experience. So privacy, performance, reliability, that's the 3 legs of the stool that we really kind of that drive our product development.
It makes a lot of sense. From what I know, because of the terms of use policies, Google and Facebook, and I mean, who knows what data they're collecting, but they're probably collecting a ton of super personal data. It would be nice to be able to use AI tools like they use without having to use their services. And one thing I've noticed from cloud is that you can have access to your own data cut off because of a billing issue or a hack, or there's all kinds of issues with it. Your data can be hacked and stolen. Again, you could be cut off. Let's say you pay someone, I don't know, $5 or $7 a month for access, and they shut off your access for some reason. Those are all problems as well. So I understand what you're saying. It makes a lot of sense.
Yeah, it is there is quite a bit of data out there. When it comes to that sharing of data, even with a third party, as long as the permissions are clear with the third party, and that expectation is set between the consumer and the provider of the service, it tends to be a much more clean situation. But there is so much that you can do locally without the need for any sort of dependency, whether it is a third party that you have to connect to. It becomes less of an issue if you're able to do everything locally.
In terms of computing power, let's say on a smartphone, is that enough to run these AI applications, and why now as opposed to not before? Is it just becoming enough, or has it been enough for quite a while, or where are we at with that?
Yeah, so I think I mentioned earlier the work that we have done. I'll give you a little bit of background. The work that we've done, and we started working or looking at kind of neural networks, spiking neural networks, deep learning, going as far back as 2008. So a lot of research that we've done in hardware, software, algorithm development, some training, but training really isn't our bailiwick. We're really focused on providing the inference engines, if you will, at the edge. Over that 10-year period, it's just within the last 3 years that the compute capability has been there, the software, specifically the algorithms, and the data, the abundance of data that's been available. That's kind of the trifecta that led us to the path of releasing our first, for lack of a better term, mobile AI platform in what was the Snapdragon 820 processor. That was 3 years ago. And that was the first SoC in our portfolio that we had optimized to be able to run convolutional neural networks and LSTMs and RNNs on the device. Things were at that time were a little bit bound to the CPU. That was the primary kind of compute, or the application processor was the primary compute block where all this was run. And that was, again, 3 years ago, first generation. Fast forward to the next gen, which is the following year, we introduced Snapdragon 835, and at that point, we introduced something called the Snapdragon Neural Processing SDK, and it's a heterogeneous software framework that provided access to not just the CPU, but also acceleration via our Adreno GPU and our Hexagon DSP, and specifically the vector processing units of our Hexagon DSP. So with Snapdragon 835, we provided access to all the primary compute elements, and if you compare the performance of those different architectures, the GPU performs on average, if you use like an Inception v3 benchmark, the GPU tends to run 5 times faster than the CPU, and our Hexagon DSP on the vector processing units can deliver another 50% to 2x upside. So you're really going from the baseline common denominator of CPU to DSP, you get 10x performance improvement. And that's with mostly existing hardware architectures, but a lot of optimization in being able to process different precisions of networks. As an example, you train a model in 32 float in the server or in a desktop, and if you want to run that on a mobile device, you can do that in full precision on the CPU, but you can also, with quite a bit of optimization, quantize that model and convert that model to run, let's say, an 8-bit fixed, which we do quite well on our Hexagon DSP. So there's a lot of optimizations over these past 3 years in existing, just the existing hardware architectures that have proven that the time now is right for being able to migrate, and right now in a more accelerated manner, migrate AI-driven use cases to the device. And those use cases are varied in nature, but most of them are primarily vision. So you get a lot of object detection, scene classification. I mentioned the face detection and recognition, In the audio domain, simple keyword or wake word detection, deeper natural language understanding. There's quite a bit going on with language translation on the device instead of having to rely on the cloud to translate text or a voice. And then there's some emerging use cases in systems improvement. So being able to improve the performance of the device itself over time by way of being able to leverage consumer behavior to better manage the resources on the device. So this past 3 years has actually been quite exciting, and it's moved extremely fast. I mean, to the degree that we see white papers come out, and within 2 weeks our customers are demanding that we begin implementation, where peer review for white papers usually would last in other domains 6 to 12 months. We're seeing, as short as 2 weeks before we're getting demands to be able to commercialize what is a brand new twist on an existing or a completely new algorithm.
Well, in the eyes of consumers that don't even know what's happening underneath the hood, what are they experiencing, when using your devices that you power?
Yeah, that's a great question. And one thing that we look at, at the end of the day, for this all to work, the consumer shouldn't know and shouldn't really care what's going on under the hood. What they should know is that the user experience itself is one that is compelling, delivers delight, it's seamless, and isn't going to hit the battery in an inordinate way, like drain the battery because the energy consumption is too high. But something as simple as using your face, the template of your face to unlock the phone, is a convenience that, as it's become more commonplace, although it's still, I think it's still an emerging area, but consumers are becoming more comfortable with that. Rather than key in a password or use a fingerprint, your face is now your identifier. And when that happens real time on the device, it's noticeable. If you have to wait 2 seconds for the device to open up, that can be a little bit annoying. The other is if you look at the audio world, there are at this point, I guess, myriad personal assistants that are in the market. And if you're accustomed to using a personal assistant, one of the things that you may have noticed is there tends to be pauses in between a request and the return of an answer or context that you've requested from the cloud. Being able to do some of this on-device processing, the detection of the word or even the translation, that interaction with the device, whether it's a phone or a speaker, is less of a mechanical dialogue or command and control sort of behavior, and it becomes more conversational. So fewer pauses means real-time communication, and real-time communication is more human, for lack of a better term. So these are the kind of experiences or the kind of experiences and benefits that I think consumers are starting to take advantage of. And over time, I think they're going to expect it to just be there. It's not a matter of having to tell them, oh, this is an AI-driven feature. Right now, there's a fair amount of marketing that pushes some of these things because it is a new tech domain, and the performance is actually quite interesting and better than classic algorithms. So it's time to call attention to it to some degree. But over time, consumers are just going to expect that this is what they should get, and those experiences will become more personalized to their tastes, to their behaviors, for things that they want to do, want to buy, and it'll be seamless. They won't have to think about it.
Yeah, you said that people are clamoring for certain things. What are, from the consumer side, what are they looking for, whether it's out there or not? What's the hottest stuff that people want right now?
Yeah, there are a couple of answers to that question, and some of it's really regional based. I mean, if you're in the United States, there are manufacturers like Motorola who are providing their customers with ways to identify landmarks around them, so they can hold up their phone and they can detect specific buildings or landmarks and do all that locally, that object detection or landmark detection locally on the phone, and then reach out to the cloud out in the internet and pull down context about that particular landmark. So you get this instant gratification of, that's what that place is, and then you have the pull of context from the cloud that provides, let's say you're at Sears Tower, and that context comes back and it'll give you the architect of Sears Tower, how long it's been around, any other metadata that's relevant to understanding more about your surroundings and where you are. A big area, I think this is probably the most interesting. I find it to be one of the most fascinating, and it's also where AI is going to be necessary and highly relevant given the complexity and the kind of the burden that these experiences will place on the device. The category of XR, extended reality, which is inclusive of augmented reality or virtual reality, one being more open, blending the real world with a digital world that adds layers and context, and the other being a fully immersive virtual world, like an escape experience or a completely different immersive experience. We see this category as being probably the biggest consumer of the compute that is on a device today, just for graphics and video processing. But as that particular tech domain expands, it's AI that's going to accelerate the growth of that category. You'll have everything from hand and gesture tracking driven by neural network algorithms, your voice, being able to command and being able to tell your voice from another voice, being able to do 3D reconstruction of the environment that you're in, let's say a full XR world, a full XR experience, where the algorithms will detect the scene around you on the outside of your headset, and then place virtual objects around the obstacles in your physical world, so that you can safely navigate around them and not have to walk into a wall or a table. The possibilities are really endless. But that category specifically is one where consumers have become very adept and very interested in those fully immersive XR experiences, and that is really pulling the most out of the existing compute for, again, general processing, but also AI processing.
What's the most near-term experiences that are coming that you can talk about?
I think the ones that I've mentioned so far are all there, very much out in the open. I think on the XR AR side, what I was mentioning about the different types of tracking of gestures, hands, objects in the field of view, those specific features, if you will, they're the ones that are going to take these XR experiences further in the next 6 to 12 months. There's a use case that we've been talking about quite a bit lately that we think is really not only taxes the device itself as it relates to processing, let's say, AI or neural network algorithms, but the connectivity between those devices, which, as we haven't talked about on this call or on this podcast yet, but the dawn of 5G connectivity, which will bring about, I'll say, hyperconnectivity between devices, whether it's the device to the cloud or device to device. That's going to enable some interesting things in the area of translation. So today, you can have a conversation with somebody and in another language on the other side of the world. Let's say I'm in the United States speaking English, and somebody, a colleague or a partner, could speak Chinese, and you can translate, but the translation is short sentences. It takes a lot of time. Even with local processing, it's not up to the point where it's fluid. But in the next 12 to 18 months, you'll be able to have a full video conference with somebody on the other end of the world or other side of the world. And not only will that translation take place real time thanks to on-device AI as well as 5G, but you'll even be able, or developers will be able to, let's say, morph the face of the individual so that when they are speaking, like say I'm speaking English, but on the other line, if the audio is Chinese, my mouth can actually be moving as if I'm speaking Mandarin, as an example.
That's weird.
Yeah, it's an interesting dynamic. Today, there's some of this happening with just avatars, which will probably last for a while. But there's technology out there today where you can morph the way somebody looks. In fact, in China, I've been told anecdotally by my colleagues and partners that teenage girls will not post pictures of themselves without beautifying their faces. And just some slight augmentation all of which is being done on the device with a trained neural net to improve the shape of the face or change the shape of the face, change eye colors, what have you. But yeah, that ability to morph the face of somebody as they're talking in real time, I mean, the technology's there, it's just getting more efficient.
Very interesting. So is it at the point where I can have a conversation just by phone with someone and speak my language and the phone will translate and the other person will hear their language, or is that not here yet?
You could do that, but it's still not quite ready for prime time. I mean, you can translate, but it's shorter sentences and not to the point of being conversational. It's almost like having a translator with you. If you're going to speak and then wait for something to be rendered on the other side, it's not a fully real-time experience yet.
It's getting close. Okay.
Getting close.
Interesting. What are some of the the big deals that are coming? Anything else besides what you mentioned? Any things maybe that are a couple years out, but really super ambitious that's being worked on?
But nothing else other than what I've mentioned. I think going back to that XR category that I was discussing, there's a point where if you're going to render, high-end, high-resolution graphics, doing things in real time with full depth, where a device is it's going to reach its own compute capability, especially if you're trying to do something in the realm of a handset form factor. But what we see down the road is if you combine on-device AI with 5G connectivity, you'll be able to you kind of split the burden between the phone itself or the device itself doing some of that local processing, and then some, let's just call it an edge server somewhere. It could be proximal within that local area network, or it could be somewhere on a wide area network that would be close enough to minimize the latency so that you can have purely real time and deliver not just the AI and the intelligence piece of it, but render high-end seamless fluid graphics on a small form factor device. There's a ton in terms of improvement around just the graphics and the fluidity of XR. So I think that when you have AI and 5G, you've got the device playing a role, sharing a burden with a proximal kind of an edge server, if you will, and that user experience is just going to get more and more immersive and more compelling. That's one example I can think of. And then there's the whole realm of autonomous driving, where everything that you do, whether it's driving and looking out the road, or you as the navigator working to that point of being fully autonomous, and then just everything inside of the cabin. That entire cabin is going to be personalized to you, whether it's how you sit in the seat or the forms of entertainment that you have inside the cabin, climate control. All of that is going to be, highly tuned to you as a driver, as a person, your personal taste, and then autonomous navigation of the world around you without you having to think or even have a steering wheel to control. I think that, to me, that entire autonomous driving experience is going to be heavily dependent on AI, and not just anything. It's really going to be on device. You have to make the car has to make split-second decisions, especially in the cases where something jumps out in the middle of the road, have to discern between an inanimate object and a human being. If you have to rely on a connection and that pattern match or that detection is slowed down because of you having to do round trip to another source, there are lives at stake. So in general, I think the automotive category is one that is going to be one to watch in the next 3 to 5 years.
And no one wants to call 911 and be put on hold.
There you go.
Will there be a way for, there probably is already, for devices to access, if necessary, cloud-based applications, but keep the local data private and encrypted, let's say facial recognition or other things like that? Is there going to be any need for, an interface like that?
Oh, yes. And there already is. I think you bring up an interesting point. It's not just about doing that processing, but it's also the securing of that data. in our portfolio, in the Snapdragon portfolio, we have myriad security options for developers to have their algorithm secured on the device, the personal data, be it the fingerprint or, at some point they're doing a retina scan, or your voice, not your voice, your face, as we just mentioned. Securing all of those, all of that biometric data at rest is also key, and we have a variety of tools. We have a secure processing unit. We have full support for Trust Zone, a secure execution environment. So whether it's the protecting of the AI algorithm, the protection of that personal data, the biometric data, or the execution of the algorithm against that data, that entire end-to-end on the device and securing that data is hypercritical, something that we do quite well and we'll see become commonplace in the industry in the next couple of years.
Well, very good. So what's the best way for consumers, businesses, et cetera, to reach out, for collaboration, to find out more about what you're doing, to look at your line of processors? What's the best way to contact you or the company?
Yeah, well, I think when it comes to from purely an AI standpoint, developers that want to build applications, we make it very easy for them. If you go to our developer portal, it's developer.qualcomm.com. One of the primary entry points would be to access a page for our Snapdragon Neural Processing SDK. That SDK is one that you can embed in any app. You can find models for object detection and voice recognition. Probably not. Actually, I shouldn't say voice recognition, but certainly object detection and classification. You can find models all over the internet, open source, and start building applications today with that tool. And run it on a standard Snapdragon-based product. It could be a Samsung Galaxy or an LG device, Motorola, Sony. If you're in China, Xiaomi, Oppo, Vivo, all the major handset manufacturers are running Snapdragon products. So you don't really need a developer kit. You just use your phone, the SDK, and start building applications. But through the developer portal, that's the best way to get in touch with us if you're interested in learning more about what we're doing in the world of AI around Snapdragon.
Well, very good, Gary. Thanks for being on the podcast, and great stuff ahead. I really appreciate you being here.
Yeah, my pleasure. Thanks for the opportunity to chat. It was great talking to you.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.